February 28, 1942, 2:47 a.m. The English Channel, 30 miles south of Portsmouth. Dr. Reginald Jones grips a metal box the size of a suitcase. Inside, the most important piece of German technology ever captured intact. His hands won't stop shaking, not from the cold North Sea wind, not from the gunfire still echoing across the water, from what he already suspects this machine will reveal. The Würzburg radar dish sits in the patrol boat beside him, dismantled into sections by Royal Engineers, who worked under machine gun fire for 11 minutes. 11 minutes to steal Germany's secret. 3 British paratroopers died buying those 11 minutes. Jones knows their names. He knows what they died for. Before we continue with Dr. Jones's incredible discovery, we need your help to keep these forgotten heroes alive. If you're already hooked by what you're hearing, hit that like button right now. It tells YouTube to share this with more people who care about real history. Subscribe to this channel so you never miss another story of courage and innovation from World War II. And here's something we love. Drop a comment below and tell us where you're watching from. Your country, your city. We have viewers from Buenos Aires to Berlin, from Manila to Montreal. Are you a veteran? Did your grandfather serve? Do you have a connection to this war? We want to hear from you. Now back to the English Channel, February 28, 1942, where Dr. Jones was about to unlock the secret that would explain why Germany was losing the war, even though nobody knew it yet. Reginald Victor Jones was 30 years old, 5'7", born in Dulwich, South London, to a middle-class family that couldn't afford university. He won every scholarship available, Oxford Physics First-Class Honours. By 1939, he was working in a cluttered office in the Air Ministry, analysing German radio signals that nobody else understood. They called him RV because 2 other Joneses worked in the building. R.V. Jones, the short scientist with thick glasses who never raised his voice and never made mistakes. The man who proved the German beam-bombing system existed when everyone said he was crazy. The man who found the Knickerbein navigation beams and saved London. But the Würzburg was different. The Würzburg was the system they couldn't crack from a distance. It operated on centimetric wavelengths, shorter, more precise, nearly impossible to jam. British bombers were dying. Between November 1941 and February 1942, Bomber Command lost 274 aircraft over occupied Europe. Most shot down by flak directed by Würzburg radar systems that could track a Lancaster bomber at 40 miles. RV knew the statistics. He'd calculated them himself. 42% casualty rate on Berlin runs, 51% on Hamburg. If the numbers continued, Bomber Command would cease to exist by autumn 1942. They'd run out of trained crews before they ran out of aircraft. But they had no idea how Würzburg worked. No manual, no photographs of the internals, nothing captured. The Germans defended their radar stations with fanaticism. Destroy the equipment before capture. Standing order. Every radar station wired with demolition charges, until Bruneval. Lieutenant Commander Friedrich Steiner was manning the Würzburg station at Bruneval on the Norman coast. 28 years old, Munich. Drafted in 1939 straight from Technical University, where he'd been studying electrical engineering. The Luftwaffe recognized talent. They made him a radar operator instead of infantry. Steiner loved the Würzburg. He'd written his mother about it. Letters the British would find years later in captured mail. It's beautiful, Mutti. Like a telescope that sees in darkness. We can track a mosquito at 20 kilometers. He wasn't exaggerating. The Würzburg could detect a single bomber at 70,000 meters, paint a perfect picture on the oscilloscope. Direction, altitude, speed, all in real time. The British didn't know any of this. They knew Würzburg existed. They knew where stations were located. They'd seen reconnaissance photographs of the distinctive parabolic dishes. But the internal workings? The components? The engineering philosophy? Complete mystery. R.V. Jones had spent 18 months trying to understand Würzburg from intercepted signals alone. Wavelength approximately 53 centimeters. Pulse repetition frequency, 3,750 pulses per second. But how did they generate the signal? How did they achieve such precision? What kind of valves were they using? What oscillator design? No answers. Only dead air crews. Then, December 5th, 1941, Flight reconnaissance photograph 4062F. A Spitfire, flying at 32,000 feet, captured something extraordinary, a clear image of a Würzburg installation at Bruneval, positioned near the cliff edge. Isolated, only 12 German soldiers visible in the area, a wooden hut beside the radar dish. R.V. Jones looked at that photograph and realized something. The station was vulnerable, accessible from the sea, close to the cliff, lightly defended, and positioned stupidly. Whoever chose the location prioritized radar coverage over security. He walked into Combined Operations Headquarters and said 6 words: "We need to steal that radar." The planning took 11 weeks. Operation Biting. 120 British paratroopers from C Company, 2nd Battalion, Parachute Regiment. 12 Royal Engineers trained specifically to dismantle radar equipment in darkness under fire. Objective: drop at midnight, fight to the radar station, dismantle and remove the Würzburg, extract by sea before German reinforcements arrive. Expected casualties: 30%. Time on target: 90 minutes maximum. R.V. Jones gave the engineers a shopping list. Specific components he needed: the oscillator assembly, the receiver unit, the power supply, the antenna feed, even screws and washers, anything that might reveal manufacturing methods. He drew diagrams, labeled everything, told them, "If you can only get one piece, get the oscillator. That's where the secret is." Major John Frost commanded the paratroop company. 29 years old, Devon, professional soldier. He'd never done a combat drop. Nobody in the British Army had. Paratroops were new, experimental. Frost's men had 6 weeks of training. 6 weeks to learn how to jump from aircraft, land in darkness, navigate by stars, and assault a fortified position. They practiced on a mock-up Würzburg built from reconnaissance photographs. Full scale, constructed on the south coast. Frost's men assaulted it 27 times, daylight, darkness, rain, until they could navigate the approach blindfolded. Flight Sergeant Charles Cox was the lead engineer, 32 years old. Birmingham, civilian job, radio repairman, pre-war hobby, amateur radio operation. The RAF made him a radar mechanic. Cox had disassembled British radars hundreds of times, could do it in darkness, could identify components by touch. But British radars were British. German engineering? Unknown territory. R.V. Jones spent 3 days briefing Cox personally. The Germans build things differently. Heavier, more robust, more precise. Their philosophy is different. They'll use more components where we use fewer, better quality, tighter tolerances. You won't be able to just unscrew panels. You'll need to cut things, pry things, break things. I don't care if you damage it, just get it out. Cox asked one question: "What if it's booby-trapped?" Jones didn't blink. "Then you'll die and we'll still lose, so be careful." February 27th, 1942, RAF Thruxton Air Base. 11 Whitley bombers lined up in darkness, 120 paratroopers boarding. Each man carrying 80 pounds of equipment, weapons, ammunition, explosives, radios. Cox and his engineers carried toolkits, special tools manufactured specifically for this mission: bolt cutters, pry bars, hammers, screwdrivers with specially hardened tips. Frost gathered his company. Short briefing. The radar is the objective. Everything else is secondary. If we lose every man but get that radar home, the mission succeeds. If we all survive but lose the radar, the mission fails. Understood. 120 voices. Yes, sir. They boarded the aircraft. Lieutenant Ewan Charteris was Frost's second in command, 26 years old, Edinburgh. His family owned a printing company. Charteris had joined the Territorial Army in 1938 because he thought war was coming and wanted to serve with friends rather than strangers. His best friend from university, Peter Young, was jumping with him tonight. They'd made plans. After the war, they'd start a publishing house together. Charteris and Young ladded 50-50 partnership. They'd shaken hands on it, discussed it for hours during training, what books they'd publish, what authors they'd seek, where they'd locate the office, Edinburgh or London, maybe both. The Whitleys took off at 22 and 15 hours, tight formation, low altitude to avoid radar, crossed the channel at wave height, climbed to 1,200 feet over the Norman coast, midnight, moonless night, perfect blackness. The drop began at 00:15 hours, February 28th. 40 seconds of hell. Men tumbling from bomb bays into freezing darkness, parachutes snapping open, the sudden violent deceleration, then silence except for wind and the distant sound of aircraft engines fading. Frost landed in a snowdrift 200 yards from the drop zone. Charteris landed in a tree and hung there for 90 seconds before cutting himself free. Cox landed perfectly in an open field and immediately began checking his tools. Peter Young landed in a ditch and broke his ankle on impact. Young tried to stand. Couldn't. Knew immediately. He called for Charteris. "It's broken, I can't walk, leave me." Charteris refused. "We'll carry you. You'll get everyone captured. The mission—" "Shut up, Peter." But there was no time. German voices in the distance, shouts, dogs barking. Frost made the decision. "Hide him. We'll collect him on extraction." They left Peter Young in a barn with his rifle and 4 morphine syrettes. Charteris squeezed his shoulder. 2 hours. We'll be back in 2 hours. Young smiled. "Get that radar, Ewan. Make it worth it." They moved out. Frost's company, 113 men now. 7 scattered on the drop, lost in darkness. C Company moved toward the cliff edge, toward the Würzburg. The radar station sat 300 yards from the cliff, surrounded by barbed wire and minefields. 2 searchlights, 4 machine gun positions. The Würzburg dish itself was mounted on a concrete platform, rotating slowly, tracking something. The wooden equipment hut sat beside it. Inside that hut, Friedrich Steiner and his crew, 3 men, monitoring scopes, tracking a British bomber stream heading toward Paris. Normal night, routine operations. Steiner was drinking ersatz coffee and complaining about the cold. The hut had no heat. Regulations. Heat generated electromagnetic interference. At 00:42 hours, Frost's men cut through the wire, silent, no alarms. The Germans had become complacent. This station had never been attacked, never even approached. The war was elsewhere. The Eastern Front, North Africa. Not here on a forgotten clifftop in Normandy. The first German sentry died without making a sound. British commando knife, 7 inches through the ribcage. The second sentry managed to shout before a Sten gun burst cut him down. Then everything erupted, searchlights blazing, machine guns opening fire, flares shooting into the sky, German voices screaming alerts. The radio in the equipment hut crackled with urgent messages. "Station Bruneval under attack. Enemy paratroopers. Send reinforcements." Frost's men assaulted through the wire, grenades into machine gun nests, suppressing fire, close quarters fighting. The British had surprise and training. The Germans had fixed positions and support weapons. 3 minutes of absolute violence. Flight Sergeant Cox ran through the chaos toward the equipment hut, bullets snapping past, explosions, screaming. He didn't look at any of it. Only the hut. Only the mission. The door was locked. Cox kicked it open. Steiner and 2 German technicians inside, hands up immediately, no resistance. Cox ignored them, his eyes locked on the equipment. There, the oscillator assembly, mounted on the wall, heavier than expected, more complex, more components. Cox started disconnecting cables, unscrewing brackets, his hands steady despite the gunfire outside, despite the fact that at any moment a bullet could come through the wooden wall and kill him. The other engineers piled into the hut. Cox shouted orders. "You, get the receiver unit. You start on the antenna feed. You grab every manual, every piece of paper, everything in that filing cabinet." Outside, Frost's men secured the perimeter. 14 Germans dead or captured, 3 British soldiers wounded. The firefight lasted 6 minutes. Now came the hard part. Dismantle the radar. Carry it to the beach. Hold the position until the boats arrived. Cox worked with bolt cutters on the oscillator. The Germans had secured it with specialized screws. Anti-tamper design. The heads were unusual, 12-point pattern Cox had never seen. Couldn't get a screwdriver into them. Had to cut them. Each screw took 40 seconds. There were 18 screws, 12 minutes, sweat pouring down his face despite the February cold, hands cramping. Finally, the oscillator came free. Heavy, 60 pounds, wrapped it in canvas. One of Frost's men took it. "Guard this with your life. If we lose this, men died for nothing." The receiver unit came out easier. Standard screws, 6 minutes. The antenna feed was external. They just unbolt it from the dish mount. The manuals and documents filled 2 canvas bags, operational logs, maintenance records. Even Steiner's personal notebook with handwritten calibration notes. 23 minutes total. Cox looked at the gutted equipment hut. British radar stations could be disassembled in 8 minutes. German over-engineering added 15 minutes. 15 minutes under fire. 15 minutes where men could die. They hauled everything toward the beach. 4 men carrying the oscillator. 2 carrying the receiver. 1 carrying the antenna feed. Others carrying documents. Frost's company covering the withdrawal. German reinforcements approaching. Headlights visible on the coast road. Trucks. Maybe 200 soldiers. The beach extraction point, 01:27 hours. The Royal Navy boats weren't there, supposed to arrive at 01:30. 3 minutes. Frost's men formed a defensive perimeter. German troops advancing from inland, machine gun fire starting, mortars. The situation deteriorating rapidly. No boats, still no boats. Frost radioed the Navy. "Where are you? We're taking fire. We need extraction now." Crackling response. "Delayed by E-boat patrol, 5 minutes out." 5 minutes. An eternity under fire. Peter Dawson died at 01:36 hours. 22 years old. Leeds. Machine gun burst through the chest. He'd been carrying the oscillator. Fell forward, protected it with his body even as he died. His squadmates grabbed it from under him and kept moving. Timothy Ross died at 01:38. Mortar fragment through the neck. 20 years old. Glasgow. He bled out in 40 seconds. Nobody could stop to help. The withdrawal was chaos. Running firefight down the cliff path. Germans closing from 3 sides. Charteris made it to the beach. Looked back toward the barn where they'd left Peter Young. Smoke rising from that direction. German troops everywhere. No chance of recovery. His friend was gone. Either captured or dead. The publishing company they'd planned would never exist. At 01:41 hours, 6 Royal Navy landing craft appeared through the darkness. Engines roaring, ramps dropping, Frost's men splashing through the surf, loading casualties, loading equipment, loading the precious radar components, German machine guns firing from the cliff top, bullets hitting the water, hitting the boats, Royal Marines returning fire with mounted guns, covering the extraction. One landing craft took 27 hits, kept running. Another had its engine damaged, kept running anyway. At 01:47 hours, the last British soldier boarded the last boat. Total time on target, 92 minutes, 2 minutes over schedule. The boats pulled away from the beach, German fire pursuing them into the darkness. One boat trailing smoke, all boats overloaded, men standing because there was no room to sit, wounded lying on equipment. Flight Sergeant Cox sat on the deck, the oscillator between his knees, arms wrapped around it. Blood on the canvas from Peter Dawson. Cox was crying, not from fear, from relief. They had it. They actually had it. The cost. 2 men confirmed dead, 6 wounded. Peter Young missing, presumed captured. 7 men scattered on the drop, 4 later confirmed captured. 3 evaded and returned to England over 4 months. Total casualties, 18%. They'd gotten the radar. R.V. Jones met the boats at Portsmouth at 04:20 hours, dawn breaking. He walked onto the dock as Cox carried the oscillator off the landing craft. Their eyes met. Cox just nodded. Jones took the canvas-wrapped box like it was made of glass. 3 hours later, in a locked laboratory in the Air Ministry, Jones began the dissection. 15 scientists, photographers documenting everything, every component catalogued, every wire traced, every connection mapped. The first surprise came within 20 minutes. Jones opened the oscillator housing and just stared. Nobody spoke. The internal components were beautiful, precisely machined, perfectly assembled. German engineering at its finest. Copper components polished to mirrors. Wire connections soldered with extraordinary care. Every part marked with serial numbers, manufacturing dates, inspector signatures. But something was wrong. Jones felt it immediately. Too much precision, too much care. This wasn't mass production, this was handicraft. He examined the main oscillator valve. It was enormous, twice the size of equivalent British valves. Beautifully made, hand-assembled. Each component inside the valve individually adjusted and calibrated. The valve casing had inspection marks from 5 different technicians, quality control stamps, performance certification. One valve had 17 separate inspection marks. Jones turned to his deputy, Dr. Robert Cockburn. "Bob, how long do you think it took to make this valve?" Cockburn examined it, did calculations. If they're doing individual calibration, testing each stage, maybe 10 hours, 12 hours for one valve. The Würzburg used 7 specialized valves. Jones pulled out the receiver assembly. Same story. Hand wound coils, individually matched components. Tolerance specifications tighter than necessary. Every resistor hand-selected for exact value. Every capacitor tested and certified. One of the engineers, Harold Jackson, radar specialist, pointed out something crucial. "Sir, look at this. These resistors, they're not standardized, each one is slightly different. See? The manufacturer adjusted each one individually to hit the target resistance. That's why they're marked with inspector codes." Jackson was right. British resistors came in standard values, mass-produced, good enough, plug them in. If one breaks, replace it with an identical unit. The German resistors were individually crafted to precise specifications. Impossible to replace in the field without recalibration of surrounding components. The analysis continued for 8 days, around the clock. Every component examined, measured, tested. The scientists filled 4,000 pages of technical documentation, every discovery more troubling than the last. The conclusion was devastating. The Würzburg was technologically superior to British radar. Better sensitivity, better precision, better range, better resolution. In every measurable category, the German radar performed better. But it was impossible to mass produce. Every unit required hundreds of hours of skilled hand labor, individual component selection, manual calibration, precision assembly. The Germans had prioritized ultimate performance over manufacturability. R.V. Jones did the mathematics. The Würzburg represented approximately 320 man-hours of highly skilled labor. The equivalent British radar, the Type 7, represented approximately 8 man-hours, mostly unskilled assembly line work. A 40-to-1 difference. He pulled manufacturing statistics. Germany was producing approximately 12 Würzburg units per month across all their electronics factories. Britain was producing 500 Type 7 units per month from 3 factories. The numbers told the story. For every German radar, the British produced 42. Jones wrote the analysis personally, 27-page report, classified most secret, delivered to Churchill's War Cabinet on March 19, 1942. The key section read, "The captured Würzburg radar demonstrates Germany's fundamental strategic error. They have chosen perfection over proliferation. Each German radar is a masterpiece of engineering, but engineering excellence cannot compensate for numerical insufficiency. The enemy manufactures weapons as artworks. We manufacture weapons as products. In warfare, quantity has a quality of its own. Germany is losing the industrial war." The report included devastating comparisons. German Tiger tank, 10,000 man-hours to build. American Sherman tank, 800 man-hours. German tank was superior. Americans produced 13 Shermans for every Tiger. German Focke-Wulf 190 fighter, 8,000 man-hours. British Spitfire, 4,000 man-hours. The Focke-Wulf was marginally better. Britain produced 2 Spitfires for every FW-190. Everywhere the pattern repeated. German obsession with engineering excellence created weapons that were magnificent but rare. Allied pragmatism created weapons that were adequate but overwhelming in number. Jones included one particularly brutal statistic. Between January and December 1942, Germany produced approximately 144 Würzburg radars. Britain produced 6,000 Type 7 radars, a 42-to-1 advantage. Even though each German radar was individually superior, the British radar network was collectively invincible. because of sheer density. The Luftwaffe could track individual British bombers with extraordinary precision. But when 800 bombers crossed the coast simultaneously, even perfect tracking was useless. The Germans couldn't shoot down bombers faster than British factories could produce them. Churchill read the report, made notes in the margins. His conclusion scrawled at the bottom: "They're drowning in their own genius." The analysis went further. Jones examined German manufacturing philosophy across all military equipment, discovered the same pattern everywhere. German military specifications demanded perfection, zero defects, ultimate performance. Every component tested beyond operational requirements, every assembly inspected by multiple technicians, every weapon system over-engineered. The result: German factories produced masterpieces slowly, while Allied factories produced adequate weapons quickly. British and American military specifications demanded good enough. If a component met minimum requirements, it shipped. No individual calibration, no hand-fitting, no perfectionism. Standardized parts, interchangeable components, assembly line manufacturing. If something broke in the field, replace it with an identical unit. No specialized tools needed, no specially trained technicians. Jones found purchase orders from German radar factories. One order for oscillator valves. Each valve must be individually tested at 15 test points. Performance must exceed specifications by minimum 20%. Reject any valve failing any test. Rejected valves to be returned for remanufacturing. Compare this to British valve orders. Valves must meet minimum specifications. Random sample testing acceptable. Failed valves to be discarded, not repaired. The British accepted 3% failure rate. Cheaper to throw away failures than inspect everything. The Germans accepted 0% failure rate. Expensive, but perfect. In 1942, this mattered. Germany was fighting a multi-front war. Eastern Front, North Africa, Atlantic Ocean, Mediterranean. They needed equipment everywhere simultaneously. Limited manufacturing capacity couldn't meet demand. Perfect weapons in insufficient quantities. Meanwhile, Allied factories, British, American, Canadian, Australian, were churning out endless streams of adequate equipment. Enough rifles, enough tanks, enough aircraft, enough ships, enough radar, not the best, just enough and good enough. The war became mathematics. German kill ratios were better. One Tiger tank could destroy 5 Shermans, but if 6 Shermans arrived, the Tiger lost. One FW-190 could outfight 2 Spitfires, but if 4 Spitfires arrived, the FW-190 went down. Germany couldn't replace losses. Building a new Tiger took 7 weeks. Building a new Sherman took 10 days. The arithmetic was brutal. For every German replacement, the Allies produced 49 replacements. R.V. Jones understood this by March 1942. The Würzburg analysis revealed it. Germany would lose the war not because their technology was inferior, it was superior, but because superiority without quantity is strategically useless. He included another devastating finding. The Würzburg required 3 highly trained technicians for operation. Minimum 3 years training. The British Type 7 required 1 operator with 6 weeks training. Germany didn't have enough trained personnel. Britain had excess personnel. Germany was losing the personnel war simultaneously with the equipment war. Training a Würzburg operator took 156 weeks. Training a Type 7 operator took 6 weeks. A 26-to-1 difference. Germany couldn't produce trained operators faster than they died. The report went to Bomber Command. Influenced strategy. If German radar operators took 3 years to train, target radar installations, force them to replace trained personnel with half-trained personnel, reduce effectiveness without destroying hardware, make them waste their precious training resources. The report went to industrial planning, influenced Allied manufacturing, double down on mass production. Don't try to match German quality. Overwhelm with quantity. Build 10 adequate weapons instead of 1 perfect weapon. Accept higher individual failure rates. Compensate with numbers. The report went to intelligence services, influenced targeting. German factories producing handcrafted components were small, specialized, difficult to replace. Bomb them. Even temporary disruption had disproportionate impact. Because Germans couldn't rapidly replace destroyed manufacturing capability. Their systems were too specialized, too dependent on skilled craftsmen, too fragile. By June 1942, the strategic bombing campaign had new priorities. Target specialist manufacturing, target training facilities, target skilled labor housing. Don't just destroy weapons. Destroy Germany's ability to replace weapons. The Würzburg became Exhibit 1 in the case against German industrial philosophy. Perfect example of the wrong approach. Beautiful engineering, tactical superiority, strategic suicide. American analysts got the report, studied it intensely, drew conclusions, influenced American manufacturing philosophy. The US was already inclined toward mass production. American industrial culture emphasized quantity, standardization, assembly line efficiency. The Würzburg analysis confirmed they were correct. American factories went into overdrive. Liberty ships, 1 every 4 days. Sherman tanks, 1 every hour. B-24 bombers, 1 every 63 minutes. The numbers were staggering. By 1944, American production exceeded all Axis powers combined, not because American products were better, because American factories could make them faster. Germany noticed. German intelligence reports from 1943 expressed alarm at Allied production numbers. One report, captured after the war, stated, "Enemy manufacturing capacity exceeds our projections by 400%. Enemy does not pursue quality. Enemy pursues overwhelming quantity. This is strategically effective. We cannot match these numbers." German High Command responded by doubling down on quality. If we can't match their quantity, we'll exceed their quality. Make each German weapon worth 10 Allied weapons. The Tiger II super heavy tank, the Me-262 jet fighter, the Type 21 submarine, all magnificent. All rare, all produced in quantities too small to affect the war's outcome. One Tiger II could destroy 20 Shermans, but if 21 Shermans arrived, the Tiger II lost. The math was unforgiving. By 1944, the disparity was obvious. The Normandy invasion brought 12,000 Allied aircraft against 300 Luftwaffe aircraft, 40-1 numerical advantage. Even though German pilots were better trained and German aircraft were better engineered, they were overwhelmed, shot down by sheer numbers. Couldn't land to rearm before 10 more Allied aircraft appeared. Couldn't repair damage before the next wave arrived. The Würzburg radar analysis predicted all of it. R.V. Jones had seen the end in March 1942, just needed 2 more years to play out. The cost was immense. Peter Young died in German captivity, pneumonia, December 1943, Stalag 7B, 27 years old. Ewan Charteris survived the war, returned to Edinburgh, tried to start the publishing house alone. It failed within 2 years. He became a schoolteacher. Died in 1987. Obituary mentioned his war service in one sentence. Flight Sergeant Charles Cox survived. Returned to Birmingham. Worked as a radio repairman for 43 years. Fixed televisions, car radios, hi-fi systems. Never spoke about Bruneval. Never told customers he'd stolen the radar that revealed Germany's fatal flaw. Died in 1994, age 84. Obituary mentioned nothing about the war. Friedrich Steiner survived too. Captured at Bruneval, he spent the rest of the war in a Canadian POW camp, returned to Munich in 1947. Worked as an electrical engineer for Siemens, designed industrial control systems, retired in 1981, died in 1996, age 82. His obituary mentioned he'd been a radar operator. Nothing about Bruneval, nothing about the Würzburg. R.V. Jones continued intelligence work through the war. Afterwards, became Professor of Natural Philosophy at Aberdeen University. Wrote his memoirs in 1978, Most Secret War. The book detailed the Würzburg analysis. Few people read it. Jones died in 1997, age 85. His obituary focused on his post-war academic career. The Bruneval raid got 2 paragraphs. The Würzburg that Cox stole is now in the Imperial War Museum, London, reassembled. Display card explains its German radar equipment captured 1942. Nothing about what it revealed. Nothing about the industrial philosophy it exposed. Most visitors walk past without stopping. It looks like any other war relic, old technology, obsolete components, historical curiosity. But that radar explained why Germany lost the war. Not because German engineering was inferior. Because German engineering was too good. Because perfection takes time and wars require speed. Because individual superiority cannot overcome collective adequacy when collective adequacy arrives in overwhelming numbers. The lesson applies beyond World War II. In any extended conflict, military, commercial, technological, the side that can iterate faster usually wins. Perfect products shipping slowly lose to adequate products shipping rapidly. Excellence in limited quantities loses to competence in unlimited quantities. Germany built masterpieces. The Allies built products. The masterpieces lost. This story matters because military history usually celebrates technological superiority, the best tank, the best aircraft, the best weapon. The Würzburg analysis proves technological superiority is necessary but insufficient. Without industrial capacity to deploy that superiority at scale, perfection is strategically irrelevant. The two British soldiers who died extracting that radar, Peter Dawson and Timothy Ross, died for a piece of intelligence that shortened the war. The Würzburg analysis influenced Allied strategy, manufacturing, and targeting. Lives saved by that intelligence probably number in the tens of thousands. Their names appear on no monuments. Most histories don't mention them. If this story moved you, hit that like button. These stories need engagement to survive. Subscribe so you never miss another forgotten story from World War II. And tell us in the comments, where are you watching from? Do you work in manufacturing, engineering? Does this story change how you think about quality versus quantity? We want to hear from you. History remembers the battles, the generals, the famous weapons. But wars are decided in factories as much as battlefields. The Würzburg proved it. 253 British soldiers risked their lives to steal a radar. 2 died, 18 were captured. What they brought back revealed the truth. Germany was losing the industrial war while winning the quality war. Quality wasn't enough. It never is. Thanks for keeping these stories alive. These men deserved better than anonymity. We're trying to fix that, one story at a time.